Hello everyone, good day to all. Myself Krishna Raj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology. In this video lecture, I am going to be explain about that metrology and measurements terms used in the metrological measurements. Yes, so what is metrology? Metrology is defined as the science of measurement. So all the engineering principles behind that, it will have an scientific principles. So the metrological things also, it is called to be as an science of measurements or precision of measurements. Even it can be defined as the accuracy of measurements. Okay, so in this precision and accuracy, both the words are same, but it has an different of it definitions. It has a difference in the definitions. For engineering purposes, the metrology is restricted for the measurement of length and angle and quantities which are expressed in the linear or angular terms. So the metrological things are limited only for the engineering principles for measuring of length, angle and quantities. So on which precision and accuracy. So both the words looking are same, but it has a difference of definitions. So what is precision? Precision is nothing but it is the repeatability or reproducibility of measurements, which means that, so if you are using some screw gauge or vernier caliper, the same gauge is used for measuring the particular component for multiple of times. Even if you are measuring first time, it shows an 10.1 mm. Then second time, if you are measuring the same object, same gauge, it's showing 10 mm. Then third time, if you are measuring, it's showing that 10.2 mm, means it has a good precision. So the repeatability or reproducibility of measurements, whatever the number of times given dimension is measured by using a given measuring equipment, if the same dimension is obtained for every time, then it is called to be as a repeatability or reproducibility of the measurements. Even if you are measuring a multiple of times, so definitely we cannot able to get the same reading. It has some error value. For example, 10 means 10.1, 9.9, 10, like that. So if it is called as a precision of this equipment. Then what about accuracy? The nearness to the true value. The nearness to the true value is called as an accuracy. The precise measurement made by using standard measuring equipment or non-errored measuring equipment is called as an accuracy of measurement. Whenever more than one measuring equipment is involved in the measuring dimensions, accuracy is very much important. Yes. So what about this accuracy? So if you are measuring any gauges, that particular measured value is how close to the true value. For example, I am using a vernier caliper for measuring an object, like measuring the outer diameter. It has a true value of 10 mm. If I suppose to measure that, it's showing 9.99, means it is highly accuracy of machine, high accuracy of machine. Definitely that never shows the same reading. So exactly 10 mm. It is not at all possible because of the environmental condition and error values. So it has some deviations. But how close, how nearness to the true value? You can look into this. So this is an true value, and this is the reference value, that is measured value. So how close the readings are, then it is called as an accuracy. Now we can make a difference among the accuracy and precision. Before get into this, you can look into this bottom side. It has an image, 3 images that contains. So that yellow color is an object, this one is an object, that center point white color is an true value, and these 4 blue color are the readings. So reading 1, reading 2, reading 3 and reading 4. On this first image, so it's showing that not accurate and not precise, which means that The first thing is not accurate. Not accurate. What is accuracy? So nearness to the true value. True value is this white color dot, and nearness. So all the readings are so far away from that true value. So not an accurate value, and not precise. All the four readings have their own thing. For example, the true value is 10 mm, and the measured value reading 1 is like an 8.1, and a measured value 2 is like an 8.5. Like it has a difference of the readings. So it is a not accurate and not precise. And you can look into the second image. On this second image, it is not accurate because true value is 10 mm, but the measured value is like an 8.5, like that, for example. I let you. Okay, so but it is a precise one. So why it is called as a precise? Now all the four readings are very much closer to that value. For example, 8.5, 8.4, 8.3, again 8.5, something like this. So all the four measurements using by the same gauge, same measuring gauge, and same the object, but the values are 8.5, 8.4, 8.3, again 8.5. So which means that it is a precise of reading, but it is not accurate because the true value is 10 mm. Okay, then third one is it is an accurate value as well as precise of reading, because the true value is 10 mm and all the four readings, that is 9.9, 9.8, 9.9, 9.9, like that. So the true value is 10 mm, the measured value is 9.9, so it is very much closer to the true value, it is more accurate. Then all the four readings are very much closer to that value, like a 9.9, 9.8 and 10 mm, like that. So it has a precise of value. So accuracy indicates how close a measurement is to be correct or accepted value. But the precision indicates that closeness of two or more measurements to each other. And the accuracy, the measurement will be close to the standard measurement, but the precision is measurement will be similar for every time. Okay, so accuracy is close to the standard measurement, but precision is similar for every time that you have measured. And accuracy can be improved, but precision cannot be improved. Accuracy is not dependent on the precision, precision is not dependent on the accuracy, both are different. So suppose if the accuracy of the equipment is very poor, means we can calibrate it, but the precision we cannot able to make, because so if, for example any measuring gauges we can able to calibrate and again back to the original reading measurements, but precision cannot be improved in this. So that metrology is mainly concerned with the establishing the unit of measurements. So for ensuring the uniformity of measurements and for developing the methods of measurements, for developing new methods of developments in this, and errors of measurements, accuracy of measuring instruments, how accurately that are measured, and industrial inspection and various techniques that are used for the metrology. So what are the objectives for the metrology? So the complete evaluation of new developed products and determination of the process capability. What is the process capability for the particular thing? Then determination of the measuring instrument capability. So based on that we can able to minimizing the cost of inspection. Inspection cost will be reduced and the effective time will be improved. Efficient of work and labors. So this will and the reducing the cost of rejections ultimately. So if you are improving previous point, so the cost of rejection rate will be reduced, and rework also. To standardize the measuring methods, so we can able to standardize the process workflow to maintain the accuracy of measurements, to prepare design for all gauges and special inspection of fixtures. Yes, on which we have metric systems and SI systems, that is in units which we have followed. So most commonly we are using the metric system and SI system, unit systems. So that metric systems we followed CGS. What is CGS? Centimeter for length measurement, G for gram for mass measurement, and S for seconds time measurement. So that is called as in CGS metric unit system. Otherwise we are following SI unit system. So on the SI unit system, MKS format. So M for meter length measurement and kg kilogram for mass measurement and seconds for time measurement. In most commonly we are using either CGS format or MKS format. So methods of measurements. What are the methods we have for the measurements? So commonly we have two methods, direct method, indirect method. On which direct method we can directly measure on the reference point. Like if we are supposed to measure some object means directly measured on that. So the value or quantity which are directly measured or obtained directly without any calculations. Directly we can get the readings on the measurements. So like in a steel rule or vernier calipers or micrometers or bevel protectors. So these are all the direct of measuring methods. The next one is an indirect method of measurement. On this indirect method of measurement, the first thing is, so we have to do some calculations for calculating the measurements. So like in sine bar and others, for angular measurements we have to do some calculations, then only we can get the angle of measurement. So that is an indirect method. Then second, another thing is for indirect method, like in using special gauges like an IR rays and other equipments which are used for measuring the distance or something else, it is an indirect of method measuring. Thanks for watching up this video. Thank you all.